So thank you everyone for joining this virtual Hyperledger meetup. Today we're going to be talking about a new Hyperledger Lab named Agora, and Mike Lodder will be talking about that. Mike Lodder is an active member of the Hyperledger community, a security researcher and implementer, and he will share details about Agora. And if that is something that you're interested in, just like everything in Hyperledger, it's open and you're welcome to get involved, take a look at it, check it out, and contribute. So if you are interested, hopefully you will learn some interesting stuff today, and we hope to see you in the community checking it out and contributing. So with that, Mike, why don't you take it away?
Well, cool. Thanks, David. Yeah, so Agora, at least to me, means, it's a gathering place. At least that's what it was in ancient Greek. And so I've been in Hyperledger a long time, since about 2016, since its inception. So this is a way for Hyperledger to help me out, as well as maybe help some of you out as well. So here's kind of how it got started. So Hart Montgomery and I were at a conference together talking about various things, and I have developed quite a few cryptographic libraries over the years, and lots of different companies um, have been wanting to use them in various capacities, and so then they don't have to rewrite their own code. And I've been trying to get a lot of collaboration across these. Same with researchers, and they're off and on. They're, some are lukewarm, some are more involved, some are like, well, there's reasons why we can't do that. And so I was trying to figure out why. And so Agora is one reason to fix the problem why they won't. And one of the reasons is they often say, well, you're the only maintainer, you're the only person who knows the code in and out. And then if if we contribute to it, who gets to own it? Should we make a copy and fork it into our own repos? Can we get you to sign a contract and then we'll take over the code? I mean, that kind of thing. Some of them have tried to take it over when they haven't even contributed to it. I've even gotten sued because the company wanted to steal my code from me and take it legally. So it's been kind of a nightmare off and on all these years to do that. And so when Hart and I were talking, we proposed this as a viable option, which could help mitigate many of those problems. So hence the Agora approach, which is, if you've ever been to Athens and seen the Acropolis, this is where the inspiration comes from. So we said, well, let's create a new labs project where all of that cryptography code can live. And it's a common place for any cryptography code, not just blockchain, but any that could be, donated for research purposes or used in production. The goal is that this code should be able to be used in production, and some of it is, but it will be owned by Hyperledger. I'm just one of the maintainers. And then any other new maintainers that come on, obviously they have to abide by the code of conduct. And then if I ever decide to leave, then the code will still live on and anyone else can, keep it going. So that was the idea. So a more modern day Agora, if you will, rather than the ancient version. So the main thing I'm trying to also contribute to is coding cryptography tends to be quite scary for people because they see a lot of problems that happen when you do it wrong, and they often hear the phrase don't roll your own crypto. And so the goal with this is to kind of help onboard people to the fact that, hey, sometimes you do have to roll crypto for newer algorithms and methodologies, and because there's no way around it, no one's written anything. How else would you know it would work? And I'm going to be donating quite a bit of code to it. I'm trying to get because some of my code has contributions from other people, so I'm just making sure that they're okay with the move. That's why you don't see too much in there yet. And the other parts of my code are being audited, and I'll kind of go over those in a minute. That's why none of it has primarily gotten there yet, but that is the idea. Is I'm going to be donating quite a bit of code to this to start, and then adding some new ones. I've already got quite a few researchers that are excited about it to contribute to this. And then that way we don't have to worry about the licensing or who owns it and all of that, because it'll just belong to Hyperledger, which will be nice. Here's the link if you want to know more about the main goals of Agora, but I'm just kind of touching basically on that. So again, I don't want it to seem like when you go to the supermarket and you see these really scary chilies that cryptography code is the same, right? It should be quite pleasant and fun to code in because I enjoy it. These are the initial repositories that I will be donating to the cause. I'll kind of cover what all of these are and why they exist in the first place and what problems they solve. So some of these cover cryptographically big number libraries. You may have heard there's like, big multi-precision libraries out there, but they're not safe for cryptographic use for various reasons, like they're not constant time is the main thing, or they're not side channel resistant. Some of these libraries are for MPC, multi-party computation. That is very useful for blockchains, and some of the newer cryptography I'm developing is that's coming from papers is specifically for blockchains, and thus why it's an ideal home for Hyperledger. Some libraries are for enabling safer secrets management when you're using it in memory. So we often deal with data at rest and data in transit, but no one's really written much for in memory other than say, oh, just put it in some enclave stuff like Intel SGX or AMD's 7 environment and so on, but those can be really complicated to set up. So this offers kind of a safe alternative to that. I wouldn't say you would replace all of if you've already written code for SGX and those kinds of things, that's great. Keep it there. But if, let's say you want to develop something minor, or maybe while you're just testing out some things and you're not quite ready for those more advanced enclaves, or you don't trust them yet, then that's what some of this code would be good for. The code I've written is in Rust and Golang, but the other idea behind Agora is we can expand that, and I'll talk about more about what that is later. But in either case, this should be exciting as like getting a big cake. But if you're not into cake, maybe you're big into ice cream. Either way, this should be a fun project for you to look at and participate in. So let me start with one of the biggest ones. There is a big BLS library here. If you're not familiar with that, this is what Ethereum 2.0 is planning to use. Quite a few other blockchains use it, like Sovereign does, and Definity's Internet Computer uses it, League of Entropy, and so on. BLS is becoming quite a big standard, especially among blockchains. So the library I've written here is based on this particular curve, the 12381 version. Provides all the operations you would need if you want to write your own cryptographic algorithms with using that library. There's all the BLS signatures according to the standard that's out there. They work for both threshold and non-threshold versions. It implements the Elgamal encryption, sign encryption, which is where you get a signature and an encrypted ciphertext at the same time with one operation instead of doing it twice. There's identity-based encryption in here, which I haven't seen implemented anywhere else. There's threshold encryption, which is really cool. I've added some zero-knowledge proof for signatures. So if you have a BLS signature and you don't want to leak it, you can send a proof instead, which will be verified just like a signature, but without showing the signature itself, which is really cool. That's written in Rust and Golang, and Intel has a library called Blast that is optimized for this particular curve. So you can take your pick for which one you want to use it with. And it is currently being audited. And so as soon as the audit is done, because the auditors didn't want me to move it yet, once the audit is done, it will be put into Agora, which is really cool. So the next big thing that you commonly see with blockchains is distributed key generation. Right now, I've got a Gennaro-based version in there, which has been the most popular one and safest one out there. It's got all of the verifiable secret sharing schemes that are popular out there in there. But now I'm also working with a team in Israel that they have submitted a candidate for NIST called Bingo. And it's really great in the sense that, so Gennaro, when you implement it with blockchains, it's a very synchronous algorithm in that all of the nodes have to be in the same rounds. Otherwise, they can get out of sync and they have to complete 4 to 5 rounds before you're done. Whereas Bingo is an asynchronous version in that each node only does 1 round and then they just wait for the responses from a threshold number of nodes and then they're done. And that's it. So it's been submitted to NIST, so that'll be cool. So I'm working with them to get it implemented in Rust, which is really cool. But why stop at Rust when we can do lots of other languages as needed? Okay. Big number libraries, believe it or not, RSA is still not dead, and there's still some pretty nifty algorithms we can do with this, especially when we start talking about class groups in cryptography. So we do still need big number libraries to implement some of these things. Class groups are supposed to be quantum safe, post-quantum safe, and we'll see how that rolls out to some extent, but you need these. And so some of the libraries I'm donating wrappers around the OpenSSL version, GNU's multi-precision library, and Pure Rust. And they are all constant time, which, take your pick based on speed and performance and compatibility across devices or desktops or servers or whatever. You can just pick one. So you don't even have to think about swapping out and adapting your libraries to do one of these. That's already taken care of for you. And if you're doing any blockchain based on that kind of logic, Pyre's homomorphic encryption scheme is implemented for you. I'm also adding it to be threshold based. And there's also a verifiable encryption scheme that's based on a very secure standard that's been around for a long time. Okay. Then I talked about the in-memory protection. The idea is that rather than just holding your secrets in RAM while you're operating with them, this library helps you handle it such that it mitigates some attacks like Spectre Meltdown and Hammer and RAM Bleed, which are all kind of similar, but they're complicated to deal with. And so as I've been researching and trying to figure out ways to avoid these attacks, that's what this library does for you. And also a way to tokenize authentication with symmetric cryptography, which has been pretty standard at Red Hat and other companies, but I've implemented some libraries that not only are compatible with those, but also modernizes it somewhat. So in the near future, what I'm planning to do within the next year or so is expand what language implementations I have. Like I said, most of it's in Rust, and then I do have some implementations in Go, but to expand it so it's in all 4 of those. So if you don't want to have to compile for a specific platform and you just want to work 100% in, say, .NET or the Java runtime, then you don't have to, or Golang, you don't have to wrap and go native. It'll just work because it's specifically written for those environments. The downside is you have to go with the specific garbage collection or just in time compiling for those other 3, whereas Rust, you don't have that at all. And I have implemented some wrapping that can go around the Rust for Node, Python, and WASM and C++, but the goal is to expand it. So the programming language of your choice shouldn't be an issue. And then to add some more zero knowledge primitives, because that's the area I love to work in. BBS Plus is a standard that's approaching completion. I'm also starting to work with the authors of the Ponccheval Sanders signature, specifically Oliver Sanders, because he has a version that works with elliptic curves. He's also got a post-quantum version, and they're almost interchangeable. And so I want to help him standardize those. Some cryptographic accumulators, other forms of verifiable encryption, porting bulletproofs to work for any particular curve will be really cool. And then some ZK snarks as well. So all of that will probably start making its way in there within the next year. Now, for long term, I mentioned Bingo already, but there's some other cool signing algorithms like Frost and Kate Sith for ECDSA. I'd like to add those in there so that if you are a blockchain and you want to pick out some signing algorithms and you just need it in a threshold way, they're available. There's also the idea of symmetric threshold encryption and decryption, where you don't have to worry about whether these keys will be broken by post-quantum computers, because it's symmetric based, and so you can just make it strong enough and it should just work. And then other, obviously, post-quantum algorithms that I'd love to get my hands on. Like I said, the Ponceville-Sanders post-quantum version. Some DKGs as they come out. Believe it or not, there are no distributed key generation algorithms that are post-quantum secure, because post-quantum cryptography is very, very complicated. But I know a few authors who are working on it and such. I'd like to continue researching with them and then putting code into Agora. So if you're following Agora, you'll be one of the first to know when that actually happens, specifically around the Falcon signature, since that one's very hard to get right. Okay, so like I said, Agora is a place of gathering in ancient Greek, but I'm encouraging everyone here and anyone that's not here to collaborate as much as possible. There's already a Discord channel in Hyperledger. You can come and talk about features or bugs or new things you would like to see or how you could help. I'm always looking for any kind of help. You know, you don't have to be a software engineer to help with this stuff. There's all sorts of ways you can be put to work. And specifically, try to use it in your production, because the goal is to make this code production ready. Most of it, like I said, is already being used in production systems, and let's continue to make it better. So with that, I am done. Any questions? I haven't been paying to the chat at all. So maybe I'll start.
I did have one question. And maybe a little too detailed, but the in-memory protection on mobile, this is this is sort of a big issue if you're not using a crypto that's secure enclave or trust execution environments compatible, which none of these are. So would that work in a mobile setting where the device can be rooted and other things, or is it obfuscation, or is it actually totally secure?
No, that library. So the specific one. Let me bring it up. Oh, it's not letting me. I'm gonna have to exit full screen mode here. Not that it matters, but yeah, it should work on a mobile device. It specifically is this one. So in Rust, you just do something like this. Like, here's my secret, right? And then whenever you go to use it, you just say unprotect, use it briefly, and as soon as Rust deems it's been quote unquote dropped, it's now secure again.
So if I dump the memory of the mobile device, it would be I guess if I got it at that's right at that point, it'd be there, but otherwise it would not be in memory.
Nope. As soon, like, you call unprotect, and then as soon as it's quote unquote dropped, it's gone from memory. It's wiped. So
okay, thank you.
It can sit in memory. This thing protects it, so it is still in memory. But if anyone were to try to read it, it's just garbage. So it uses this encryption algorithm, and like I said, the encryption keys for that are so large, and they're not overly large, but they're large enough that they mitigate these types of attacks. So it makes it really hard. And given that most secrets are in RAM for just say a couple of seconds, it's not going to be that big of a deal. You'll protect it, load it up. Maybe it sits in RAM for minutes, doesn't matter. As long as you're not touching it exactly at that moment, they can't get it out until you call this. See, then I get it. And then as soon as you drop it, it's zero. It's like wiped from memory, and it's protected again. And the encryption key changes every single time it's touched. So anyway, that's the idea of that one. Let me.
Thank you.
Did I answer your question?
Yes, it does. Thank you.
Okay. Let's see. Oh, Stephen Curran, have a brief description of constant time attack and side channel attack. Okay. A constant time attack is when as it relates to cryptography, not software engineering, is no matter what the input is, it takes the same amount of time to complete. There's nothing specific about the input that causes the code to run any different. This is a very dangerous thing as it relates to cryptography, because it's the only attack on cryptography that can be done remotely. So if I have code running on a server that is not constant time, as an attacker, I can send various inputs, measure the time difference, and extract a secret from that information. So that's why constant time cryptography is so important. That is the only way to attack it remotely. The rest of it has to be done through side channel attacks. And side channel attacks, you either have to be really close to the system or on the exact same system to get those to work. So a side channel is any method that when you're on the same system or network that allows you to extract cryptographic secrets. So I mentioned one which was RAM bleed or Rowhammer, Spectre, and Meltdown, which is like taking advantage of speculative branching and things like that to get the secrets to be dumped in RAM or timing, even when you're on the same machine. So that's what a side channel is. It's any other way to get at it without actually disclosing the secret directly. Okay, let's see. Can you point to an example of an MPC deployment? Yes, I can. Whoops. Lit Protocol is doing, they're not a blockchain, but they are doing an MPC as a service. So they are using a bunch of my libraries. In fact, they're the ones paying for some of the audits. And you post the link on the Discord server to what, my slides?
I think they mean where the Agora channel is, maybe.
Yeah, sorry, where the Agora channel is.
Well, let's see.
Oh, is it just it's just on the Hyperledger Foundation. Oh, okay.
Yeah, if you go to the Hyperledger Discord and scroll down, there's a section for labs.
Got it. Okay, cool.
There is a direct link to it though. I'm here. I can get the direct link and drop it.
Yeah, no one but me's posted in it. Maybe because nobody cares, but that's fine.
Well, I think it's just new and people haven't heard about it yet. Hopefully this meetup will help. So yeah, I just dropped a link to the direct channel.
Yeah. Yeah, I thought I only had 30 minutes, so I tailored it to 30 minutes. So,
Oh, yeah, I mean, as long as you like, if you want to keep going. If there's a demo or anything, I mean, not to put you on the spot, but you're welcome to have as long as you
I
like.
could walk you through probably, like I said, the biggest one that's under audit that is probably the most interesting part of it is it's called Blissful because for BLS. This is in production. You can ignore this because within another 2 weeks that I can drop this and actually give you the actual audit report as it's happening. Like I said, it's already compatible, ready to go to Hyperledger, so it's properly licensed Apache and MIT. It has already been deployed as a Rust crate. So you can see here. So I'll probably walk through this because this is more documentation rather than code. And so you might be a little scared by seeing a lot of this, but like I said, it's got all the BLS implementations you'd ever need. It's got signature proofs, all the signature algorithms, sign encryption, and then it's I say time crypt, but it's actually identity-based encryption. So there's a lot of cool stuff in here. And it's all thresholdized. So if you want to do threshold decryption, that's what a decryption share is. And this is also a wrapper around like the backend. You can pick whether you want to use, like I said, Intel's BLAST library or just the pure Rust version. By default, it uses the Intel one, but let's say you're targeting like an iPhone, that's not going to work. Therefore, you have to switch it. But it's a very simple thing. All you do is say, all right, switch from BLAST to Rust, and you're done. No code changes after that. It just works. So that's a really fun one to implement all the information you want. It also the non-creds project at Hyperledger will be using this. I recently donated a bunch of code for that. That is using this library as well. That implements a lot of stuff for anonymous credentials. So the other one that I mentioned was the big number library. Oh wait, Yeah, it actually is here. Okay. I named it unknown order, but it really does more than that. So if you want to work with hyperelliptic curves or glass groups, or even like it, the non-creds could drop all of their big number libraries and just use this one. This one's being audited as well. And it wraps, like I said, those OpenSSL, Rust Big End, and the Crypto Big End. That's all constant time. So anyway, those are probably the most interesting ones. Oh, one other one is the Gennaro one. So if you want this is being used in production, so I'm going to update it to 1.0 after the audit's done and any fixes are applied. But if you need a distributed key generation until we get bingo, this is your algorithm. Here's the paper it's based on, which is actually quite old, but it's been deemed secure by many cryptographers. So, and once I've moved these all to Agora, they'll say, the owner will be Hyperledger Agora, not just me anymore. So anyway, those are probably the main libraries. I showed you this, the other one. Oh, can you expand on what you said about symmetric threshold in your presentation? Yeah, there's an algorithm that was developed by Visa called DICE. I don't remember what it stands for, but that's the algorithm I'm looking to implement. That does threshold encryption, decryption. Let me see if I can find the paper for you. But that's the one I'm talking about. Hope that helps. Any other questions or comments, jokes? Maybe I'll comment on this. One comment or question I get often is, how is this different than Hyperledger Ursa? Well, Ursa had the goal of being the sole cryptographic library for all of Hyperledger, whereas Agora does not have that goal. It's more of a research and production-based cryptography for not just blockchains, but all sorts of spaces. So whether other Hyperledger projects use it or not, that would be great if they did, but it's not the primary goal. The primary goal is to have a community of researchers and security implementers for this stuff so that everybody can feel safe using it, because it's been scrutinized by a lot of eyes and some of it's been audited by third parties.
Mike, you mentioned you were going to post the audit report once it's done for Blissful, I think it was. Yep. That seems like a really important big step. So appreciate that. Hope that's going to happen with all the libraries so we get an idea of what's been reviewed. Yeah.
Anytime I get an audit report, I'll just put it in the repo itself.
Yeah.
Most of them come as a PDF, and those companies are aware. Like, it's Kodolsky that's auditing them right now, and they're aware that it will be made public. So
excellent. That's really good.
Yeah, Mike, and you're always welcome to, if we want to organize another one of these sorts of events in a couple months when some of the reports have come in, you're welcome to, we can do this again. We can go through the reports, and if you want to, maybe you can also have a hands-on section if you want to show people kind of how to do some of the stuff. We can structure it more as a tutorial too, if you want, if there's interest in that.
Sure. Yeah.
To follow up on Tim's question, because I know that one, I know why he's asking that one. Is that library, which library was it again? And has it been audited? What's the status of it from a review perspective?
Oh, the library,
the in-memory one.
Yeah, the library is called Soteria after one of the Greek minor gods or whatever. That one has not been audited, but it's also not very complicated. It's a very small library, but it's very efficient. So it does what it does. It follows the recommendations on how to mitigate those attacks. So I should probably link those papers in that repo, but it's there. You're welcome to take a look at it. The hard part is simulating those attacks is very difficult, right? So it's better than what you have now, I should say, which is most people just read it into memory and then it just sits there. Or then they go read it off disk. Exactly. And I don't know if that's any safer. So
yeah, exactly.
The only other option,
that's exactly what I was thinking.
Yeah. The only other option you've got is to use the key ring or the keychain, which is great. I actually do have a library for that too. And they probably will donate that as well. It's called Cryptics. I'll type it in here. that talks to all the various keychains and some encrypted databases, so you can be agnostic to what's behind the scenes. So those two kind of complement each other. So Cryptics is like, where do you store a secret when you don't want to use it? And Soteria is, when I'm using it, how do I keep it safe so it doesn't get attacked by a side channel? Neither of those have been audited, but they're minor. They're very, very simple libraries, so it wouldn't be hard to do your own audit. They're mostly just wrapping the libraries that pull secrets in and out. That's about it. They're not very complicated. I'm always accepting donations for an audit if that's another way you can contribute, because audits are very, very expensive. Alrighty, I think it looks like we're done. If there's no other questions.
Sorry, just very quickly. The Cryptics library, is that available anywhere right now, or is it like in your own GitHub, or is it?
It is on. It's in GitHub. It's public. Let me get the link for it.
Thank you. Yeah, there's tools out there where you can dump the keychain fairly easily if it's not on Clarify. Thanks.
Yep. Yeah. Oh, I know. I've written many myself.
Yep.
In fact, this tool I wrote, Cryptics, actually does just that. It will dump the entire keychain if you ask it to. Yep, that code's public.
Thank you.
All right. Well, if there's no other questions, feel free to shoot me any comments or suggestions and things in the Hyperledger Discord channel. I monitor that channel. Sadly, no one's talked to me there yet. It's quite lonely in there. I need some friends.
Well, I'll send the link to the Discord channel along with the recording and the slides. Over 130 people registered for this, so hopefully I'll send the link out to that later today. So hopefully that will get some people showing up.
Okay.
Another place to carry on with some of these things is going to be the AnonCreds group, because we are going to be using these libraries in AnonCreds v2. There is an AnonCreds v2 code base that Mike has contributed already. That is the foundations. There's a to-do list related to it, so we'd love to see contributions towards that, and that will be either directly in AnonCreds or in the Agora libraries upon which AnonCreds is built.
Awesome. Thanks everyone for coming. Appreciate it.
Great. Thanks, everyone.
Stay around.